The world is more digital and connected than ever before, which means we all are using hosted applications much more. What does that mean for developers? This implies your applications probably receive more requests every minute. I mean, if they're popular. And to keep pace, you must handle the increasing count of requests. Of course, if you want to stay in the business, how do you do that? Vertical or horizontal hardware scaling is expensive. What if you could achieve a better throughput for your microservices with the existing hardware infra by switching to Helidon 4, the first web framework that is fully based on virtual threads? Sounds great to me. But what about the size of the framework? Its external dependencies, modularity while creating its cloud native images. I mean, what's the catch? Those are good questions, but I don't have answers to them. Don't worry, because our speaker today definitely does. Hi, everyone. Thanks for joining in for another IntelliJ Idea live stream. I'm your host, Mala Gupta, and now let me add our speaker to the stream.
Hello, Mala. Hello,
Pleasure to have
everybody.
you present with us today. Sorry.
It's a great honor, and I'm really great with this opportunity to speak to this wonderful community. Thank you so much.
Uh, Thank you so much, Dmitry. It's a pleasure for us to be learning from you today, and thank you so much for accepting our invitation. And now, let me quickly introduce Dmitry. I know he doesn't need an introduction, but our obligatory part. Dmitry is a software developer on the Project Helidon, a a fellow Java champion, Oracle Groundbreaker, a very well-known and respected person in the Java community. Dmitry co-leads the Bulgarian Java User Group and also co-organizes the jPrime conference. And fun fact, Dmitry likes to travel a lot, and he also visited Arctic. So,
Yeah.
Dmitry, if I may ask, how was the experience? Was it similar to visiting other places, or was it something special?
Well, yes. By the way, from the background, you can see a picture. I'm not sure if it's visible there. I actually took
Ah,
it
yes,
being there. Yes.
yes.
So I would say it this way. It's both. It's both like you're traveling like everywhere, but then when you realize where are you, well, you have really different emotions. So on one hand, you are well, I was traveling on an icebreaker, nuclear power icebreaker, which
Oh
is
my God.
amazing by just realizing it. On the other hand, I was just having my tea and having my I don't know sandwich, just like on a usual boat. But still, what I saw from the window is an endless Arctic and some polar bears, some uh, birds. It was so impressive, and the colors are like from the other planets. And once again, the fact I was there in the summer that the sun never goes down. Actually, it just circles over you.
Yes,
It's
yes,
also
yes.
your organism, your body simply said, "Okay, I should go sleep now." But
Right.
it's like constant jet lag. On one
Hmm.
hand, on the other side, you're so much excited that you really don't need to sleep because it's so beautiful outside and cold and lovely. And yes, I wish everybody could experience that. Yeah.
Amazing experience, and
Mhm.
I could relate to some part of it because I was in Finland sometime, and we had that day when the sun did not set, and that was everything that you just mentioned. So
Yes, but imagine
I'll
like this for 2 weeks.
oh no, not done.
Yeah.
Okay, so I will quickly share some quick housekeeping details for everyone watching the session. Um, yes, this session is being recorded. No, I was supposed to say the questions first. Okay, everyone, sorry. Please use YouTube chat to post your questions. We'll try to answer your questions as you post them, and Dimitri will answer your question towards the end of the session. And yes, now the most important question. Yes, the session is being recorded and will be hosted on IntelliJ Idea's YouTube channel and JetBrains Twitch channel. So if you haven't already subscribed to our channels, now is the time to do so that you do not miss similar content in the future. And another important point, if you like today's session, which I hope you will, do not forget to like this video. And with that, Dmitry, let me add your screen to the stream and Good luck. I'll be backstage listening to your session.
Thank you so much, Mala. Well, once again, hello everybody. Hello again. So, welcome to this talk. It's a great honor to be here with you, at least virtually. So, my name is Dmitry Aleksandrov. For recent years, I was part of the Helidon team working at Oracle. Currently, I'm kind of enjoying sabbatical. That means that I need to make a break for my health issues, I would say. But anyway, I'm still like active doing my stuff, and I'm really grateful that I have the opportunity to speak to you as I would say a part of Helidon team. So I'm happy that and still actually am working on this project. Telling it from the inside is always interesting, I guess. So let's dive right into the topic. So virtual threads in action. So threads. Yes, threads is hard. Just make small disclaimer. I won't talk and won't tell you about how to use threads in Java. So I believe uh, people which come to this session or do not know how to work with threads should definitely read at least this book, which is written by my colleague Brian Gotts and Josh Block and many famous people. It is hard. I know parallel programming is hard, but we won't dive into the ideas of how and where we should use threads, but we will write how to use virtual threads and why are they actually useful and in which cases are they useful. So what are threads in Java and why actually we come to this idea of threads, and why do we need virtual threads? So if we take a look at threads in Java, they are actually quite expensive. So in terms of the way it's realized, it's implemented, it's actually a wrapper over the operating system threads. So that means that Java is simply managing all this stuff, and to manage all that stuff, we need some I would say metadata. And you see, for every thread that you start, you need at least 2 megabytes per thread of memory consumption. If you need to start a thread, you'll need at least 1 millisecond. Yes, and of course, if you need to switch between threads, it usually takes about 100 nanoseconds, or it depends on the operating system. It can take more. So if, for example, you want to start 1,000 or 1,000,000 threads, I would say, on an infinite machine, that means that it has all the amount of memory you have, all the processing power, etc., etc. You will need several minutes just to start them, because once again, it is expensive. At some point, you will even hit the garbage collection stuff. I know that it takes much more time just to handle all the resources that you have. So it's okay that in your application on a quite a, I would say, good machine, you will be able to start about 400 or 300 or maybe 500 threads and make it work like okay-ish. If you start more, you will have a lot of issues. There will be issues with memory consumption, with processing powers, well, all that stuff. So it is an issue, but we still need threads in our applications. So in case you need a lot of threads, there's something has to be done with this. And here we come to the idea that people thought about it a lot, and there was a special, I would say, research project called Project Loom. Every time when Java is developed, there are several side projects, side forks of JDK, which are research, and they're doing research on some stuff. Well, I would say dedicated stuff. There's Project Ember, there's Project Panama, there's Project Valhalla, which hopefully someday we will see, the stuff from there. in our JDKs because it's useful. And one of them was Project Loom, which was experienced something called virtual threads. And you see, the idea of this virtual thread is not something new. Many other frameworks were actually exploring this problem, and they already had some solution. For example, in Python, we already have this. In .NET, of course, everybody here, I guess, as we are on the JetBrains channel, we all love Kotlin. Kotlin has some awful Kotlin coroutines for that. I was surprised that PHP addresses this stuff and also has some virtual threads. And who was able to do this in Perl, I sincerely admire, and I say kudos to those people because I tried literally to do that in Perl and I couldn't. But anyway, there are some technologies, some approaches to use lightweight threads and save resources that way. Actually, even in the beginning, Project Loom did not use the abbreviation virtual thread. It uses more common stuff like fibers and continuations, which is more, I personally saw it more in Python stuff. Yes, and we will see all of this terminology later on. So what was the idea? The idea is that if we need a lot of threads, we need to somehow nicely manage them. And actually, it was done in Project Loom. So there were several JEPs. Java has some proposals written along the way, and it's really nice because the idea of how Java evolves now, they were actually included as preview features in earlier versions of Java, and that means that this technology was available for experimental purposes from that JEPs. Several previews, and now it is available in Java 29. But what was it actually? Let's have a look. So Project Loom. Earlier in Java, there was something called green threads. So usually I would like a reaction from the audience. What is a green thread? Do you know? But I'll give it a hint. Green thread was ability to run on one thread, several threads. Here in Project Loom, the idea is a little bit different. The idea was to run M threads on M virtual threads over N threads. So you can run multiple virtual threads on multiple, what is now called carrier thread. So the terminology is that when you start a thread, a virtual thread, JVM takes care and mounts your virtual thread on a carrier thread, on a real thread, I would say, on a typical Java thread. So there's a scheduler for that. So it searches if there is available resource and schedules it there. So whenever a virtual thread blocks, JDK knows about it. It is being unmounted from the carrier thread, making room for another virtual thread. So that means that JVM constantly looks, is your system now blocked or not? And this way, it actually reboots the block threads and puts some threads that are making work there. So once a virtual thread is unlocked, for example, there was an I/O operation happening there, and this I/O operation was, we were waiting for the file to come from the file system, and it finally arrived. So the JVM knows, okay, now I got the file, now able to do the job again. So it set it to the scheduler, and the scheduler searches for a real, or how we call it, a carrier thread to actually mount it over there and do the work for. So the main idea of JDK with virtual thread is to keep the JVM busy and not blocked with the help of this virtual thread. Underneath, there is a forejoin pool used for carrier threads. So mostly the work stealing algorithm is used. That means that it's quite effective. We know how forejoin pool is quite effective. And what's the most important, virtual threads are by API so almost the same as threads that we got used to. So that means that no much change has to be done to our software to our problems for that. And internally, it is implemented with so-called continuation. You probably heard fibers and continuation. Yes, this is an internal API, which actually makes a snapshot of your thread, of your virtual thread, a breakpoint, I would say save point. And with this method yield, and then whenever, for example, an IO operation has happened, by the way, this is important to say, all the JDK from internally was rewritten on the points where a blocking state can happen and a system can hang. This continuation yield method was added, meaning giving the JVM the idea that a signal, I would say, that here a blocking can happen, and whenever it's blocked, virtual threads make a continuation at this point, saves it, and give the thread to the scheduler whenever it's been needed for other virtual threads to be used. Yes, this is a very brief description, but once again, the main idea is now we can have millions of threads. We have the resource, not hundreds, not thousands. We literally can have millions of threads, and we can think is this as a quite an infinite resource, I would say. So these threads are always daemon threads, and they always work in virtual threads group. There are some lessons learned about how to use virtual threads from this group, but they will come later on in my talk. So we have, I'm not familiar with security manager, but since it's deprecated anyway, we don't much care about it. Yes, and there is only small changes to the API. Now we can easily get a new virtual thread executor. We can start a virtual thread as runnable, or make it a virtual, or make a factory method, and we can check if the thread is virtual or not. So this is the minimal change, I would say. So as easy as that. Well, good. Now, what is the main takeaway from what I said already? So these are the same threads. We know how they work out of this Project Loom. We are sure that actually we can have millions of them. Okay, and as my talk says, virtual thread action, we want to say where is actually the action part. And here I have to tell you a small story of actually how we came to this moment. And yes, as Mala mentioned, so as I'm part of the Helidon team, we actually decided to see how it works in Helidon. But here we need a small, I would say, pre-history part. Why is that happened? So a small introduction. So Helidon is a small framework for developing cloud-native microservices. It is a server, not a servlet. So whenever you want to create a microservice, you can take Helidon. It's definitely one of the best choices so far. You will see later why. Our main philosophy is to take as less third-party dependencies as possible, because we know Helidon is used in many institutions like banks, federal, federal, U.S. federal, services. I mean, it's governmental services. That means we need a lot of security, etc., etc. We have the philosophy to be always sync with the latest Java release, and have several flavors. Why we came to these flavors, I will tell you later. So once again, it's extremely simple. It's extremely transparent. By the way, it's the first, I believe, or it's the second Oracle's project, which is published under Apache 2.0 license, which means that you can go to GitHub and contribute. Even me now, I can, although I'm not part of Oracle anymore, for now, as I'm once again enjoying some sabbatical, that doesn't stop me from contributing whenever I want. I just go submit PRs and yay, hopefully they will be accepted. but usually they are. So once again, we adopt the latest features of Java language and encourage customers to upgrade. This means we keep it more secure, with less dependencies, and actually with bigger production. Not production, but with much better performance. Just because the JVM also, JVM JDK also is performing better with the latest versions. So as you see, we try to implement the latest stuff as much as we can. So that means that Java 20 Helidon 2 was already modular, and modularity is awesome. And now, for example, Helidon 4, you already need Java 21 because it utilizes virtual threads. So keep it up to date and encourage to update. This is our philosophy. And as I said, the main idea of Helidon is to use exactly the Java features, JDK features. That's why, unlike other competitors, you can easily package your application just as a jar, as a hollow jar. There's, by the way, a very good article, Why Should You Prefer a Hollow Jar But Not a Fat Jar, by my colleague Daniel Katz. Just go to the blog and take a look at this. It can be just a jar. It can be a custom image. That means that you throw away all the modules you don't use and your application performs better. So it's modular from the very beginning. Or, of course, for the ultimate performance with some limitations, you can just create a native image with this and it will be very, very fast. But many people don't know why, but actually Helidon has two main, we call it flavors, but I would say programming models. One is Helidon SE, which is for functional style, reactive, very fast, and with absolutely no magic inside. I mean, with almost no annotations in it. Only override annotation is used. And Helidon MP, which complies to the micro profile standard, which means that there is a lot of magic, I would say, with few annotations, which are inspired by Spring, but still I kept the community a little bit different. You will see in my code. It is compliant to micro profile. That means that you write very, very standard applications. Yes, and here is actually the idea. We still keep it separated. And why? If we take a look at the architecture, underneath we use netty for as an engine because it's very fast, it's asynchronous. On top of it, we'll build Helidon SE, which is a collection of libraries for, because when you run a microservice, it's not like simple socket to answer your stuff with text. You have to care about configuration, you have to care about security, you have to care about fault tolerance and all of that stuff. All that can happen in microservices world, we have to care about it, and seeing Helidon SE, we actually solve it. So, and on top of it, we build the Helidon MP, which complies to it's the last layer, I would say, which actually does the compatibility layer with microprofile. So why we did this? So Helidon SE follows the reactive programming model. Once again, non-blocking with back pressure mechanism. It's been designed for highly concurrent microservices, which means that we know it will be working on very, very high pressures. For example, if you book something, most probably it will go through Oracle Hospitality stuff. And Oracle Hospitality, it's everywhere. Book a hotel, you book a seat, you book a seat on a plane, or whatever it is. It goes through this system, and for example, it can really handle millions of requests per second. Helidon SE can handle this awesome pressures, and for that, once again, by following the idea that we are have to stay away from other libraries, we created our own reactive engine, once again, to keep with high pressure. And it's built, by the way, on Flow API, unlike other frameworks. They're only approaching this moment, but Helidon was already built on that. It's a set of APIs for reactive programming in Java itself, and we have this uh, uh, as a reactive operators for doing all this stuff. So that means that you can easily create reactive constructions, reactive objects, and work with them in a reactive way. For example, have a stream of objects. You can just in reactive way perform some operations on them, and they will be extremely fast. It can be multiple, it can be single, it can be like flux and mono in Spring. Here we have multi and single. Once again, and we have quite a good set of reactive operators that, of course, the main thing is the flat map everywhere. So if you do reactive, you have to do flat map. It has everything you need here. So that means that whenever you create your applications, they have to be reactive, and you have all the sets for operators in that. Once again, I won't go deeply into details because it will take a lot of time. If you want to learn more about reactive as it is, just type Venkat Subramaniam reactive in YouTube, and he has, I would say, the ultimate explanation for that. So we have our own engine, and it's very fast. It's maybe twice as fast as the competitors sometimes. But on top of that, we created our own reactive web server. That means that at the end of the day, you should do everything reactively for these high pressures. So you start with the web server reactively, you work with the data reactively, and it is extremely fast. The only thing you have to really know is once reactive, you have always to be reactive. That means that in the middle, you can't be blocking. That means that you can't write one part reactive, then block somewhere, and then continue in reactive way. No, you have to be reactive everywhere. That's why there is a special DB client to work reactively with the database, even blocking database. So it keeps it in other executors and provides a reactive API with that. And if you consume services from other microservices, you have a reactive web client for that. So once again, the idea is that you always have to be reactive. And actually, Helidon does this and does this very good. But let's be honest. I like this moment of but. It's extremely hard. I'll be honest. I know very few people that can do good reactive programming. They can think in reactive way. I know 3 of them. Oleg Dokuka. He's awesome with that. Of course, David Karnak. By the way, David Karnak, the father of reactive, also contributed to Helidon, which is extremely cool. I know, Daniel Katz, my colleague, is very good at that. Only a few people. I'll be honest, it is extremely hard for me to code in reactive way. It is hard to learn. It is hard to read the code. It's hard to write the code. It's hard to debug the code. Yes, it's extremely good for what it does, but writing it and maintaining is hard. Yes, now we know it, and that's why if we take a look at the architecture, we have this little MP part. So we made a wrapper like a next layer over it, and we complied a specification, which is a microprofile specification. It's a set of specification, which many vendors have to implement. So it's not a library or something. It's a specification how and which case should your framework behave, what test should it comply, and so on and so on. So the idea is to provide a source code compatibility between multiple vendors. So if you write your code in microprofile compatible way, you can easily migrate it to another server and its configuration, and just use it, which is awesome, by the way. So that means that you can easily migrate from one vendor to another, like standard. Like it's not Jakarta and Java EE. It's different because it's focused. There are some APIs which are in both, I would say, but in both Jakarta EE and Java and microprofile, but still microprofile has specific specifications. Well, specific may sound a little bit strange, uh, but we actually dedicated specification for exactly the microservices world, meaning that as a highly distributed system, microservices system can fail. You need to you know. Authenticate somehow. You need to take care of the health checks. You need to fault tolerate all of that stuff. Read from services. So yes, it is specific, although it is a little bit compatible. Not a little bit. Some specifications are both for Jakarta and microprofile. So in Helidon IP, we actually support multiple of these specifications. There are microprofile specific, there are standalone microprofile specification like L-Ray, for example, and there are some Jakarta E specifications that you get out of the box, and of course Helidon specific. So they work really awesome with CDI. By the way, we're proud that we have full CDI support, unlike other frameworks. I mean, microservice frameworks, which are not servlet container, and they are Graalvm compatible, which makes it quite awesome. There is one thing. They are all blocking by its nature. Well, I would say most of its part, because there are some providing asynchronous APIs, but they are blocking. Blocking means waiting. Blocking means you're losing the resources. So what we come to this trade-offs. So we have Helidon reactive stuff, which is very high performance, high concurrency, but it's scaffolding. It's hard to debug, hard to maintain, hard to learn. It does amazingly its job, but you have to find the right programmer to do this for you. Or you have MP. MP means that you have a standard approach, which is extremely good in terms of portability. You can easily find people who can write microprofile programs for you. You can easily maintain, you can easily debug and do all these normal stuff, which you do for microservices. But average performance, blocking, meaning you're losing the resources, and you cannot scale so much in terms of threads. So here are the thread board. And on the other hand, you have high performance and complexity. They have simplicity and average performance. You have to do this choice because you cannot mix this stuff together, unfortunately. So what will be the obvious solution for making simple stuff work better? Well, you have to add more threads. Nice. It will scale horizontally. Good. But, where is the performance? And here we see that when virtual threads come, this is exactly the perfect match for our workload. That means that we need more threads, and this is the solution. We have more threads from Loom. And yes, we start experimenting with this. And I won't tell you the whole story, but the idea is that we decided to create our own web server with the code name Nima, which actually was extremely simple in terms of design. We removed all the reactive stuff from the code we have and created a very basic blocking web server the way you should do it in your, I don't know, I started coding when I was in third year in school. That means I was starting in basic. That means that you do it in structural way, like a recipe. You do it the blocking way. So you just do this, then do that, then do that, then do that. That means that you actually do it like the most easy way. So the same way was written the web server, with the idea that JVM will take care of managing all of the resources that it is. By the way, I just have to turn on the lamp because I forgot that it's getting dark here. We're still winter. Yes, I hope you can see me good. So yes, so what we have, it is created a server, and we see that it performs not so bad. It actually performs even better sometimes than if you have all the reactive stuff with Netty underneath, and you do it much more easy. You don't have to think about all this reactive stuff, about all this I would say reactive operators, about wrapping your stuff in multis and singles like fluxes and monos. You can easily debug it, and yay, why should we give it a try to make a full product? And actually, based out this code name Nima, by the way, Nima means thread in Greek language, as Helidon means swallow. So we use Greek abbreviations there. But decided to create this server out of the box. So it's nice because it was built in full cooperation with Java team. Here we have some advantage between other people. We can just simply chat with those guys without them bait Presto with Brian Cutts. But hey, take a look how it performs. And it was actually released, this Helidon 4. So now Helidon 4 actually looks this way. We don't have any more netty under it. We don't have reaction. We have just two products, the Helidon SE, which is fully blocking, and Helidon MP built on top of it. So the world's first virtual thread-based server now supports everything you need out of the box. So it supports HTTP 1, 2, gRPC, WebSocket. It has wonderful unit and integration testing support built, right in the framework. Of course, MTLS, TLS, and extensible. Yes. Access log support, court support, static content. Great work with been done with the open telemetry, because open telemetry is a de facto standard for everything. And MP telemetry also follows the open telemetry way. All the observability stuff you need, it is there. We simply throw away all the reactive stuff and rewrote it in a blocking way. And we used the latest and greatest Java features because we were able to, because once again, we just rewrite it. So we use virtual threads for performance, enhanced switching, sealed classes for cleaner APIs, system logger, all this stuff just incorporate. We don't have a legacy code anymore there. And it worked. But other frameworks say, okay, we also do support virtual threads. And let's say, okay, somebody, I won't give names, say, okay, we also do support virtual threads. What is the difference? What makes the difference? So what is the difference between virtual thread support and being virtual thread based? So that means that, let's have a look how it was in Helidon before. So we have this awesome big engine. So we have several requests coming from one side. We have, in this case, only 2 threads that we can work on. So that means that, for example, there is a green operation, which is fast, and there's a red operation, which is blocking, like persistent DB, call Redis or something. So we have some tasks that we have to perform. So we read the params, which are extremely fast. So we put it on the thread. Then they called in a reactive way something else, like, for example, persist this to database. So they come to the thread and they're blocked. As they are blocked, reactive engine manages the resources and takes, for example, one of the blocked operations back and puts another thing, like read from memory, on another thread, which is now calling the send request now. And as you see, all of this going through, putting on the thread, taking out of the thread, putting there, taking it back, calling it whenever it's done, making the callbacks. It is, I would say, a lot of magic like happening. I'll be honest, it's hard to write, and all the magic that happens inside is really undebuggable. What happens in Helidon 4 right now? For example, you have several requests coming to you, and on each request, you just create a virtual threads with the set of operations that has to be done. So I'll try to improvise here a little bit. So whenever a request comes, we have, for example, only 3 threads available, 3 carrier threads. Other threads, virtual threads, are simply suspended for now because then we have not enough room. So if we go, we hit one blocking operation, and the JVM says, okay, I have a blocking operation, so let me just take over with the continuation of this thread, which is now waiting for the resource, and make it work. So as we continue, there's another thread which hits the blocking stuff. So we offload it. I would say we offload it from the carrier thread and find another thread which is actually doing something useful. Like in our case, we read something from disk, or we just, for example, find another thread which just job for us. And now, as the threads are done, they simply go. What is awesome about virtual threads is that you don't have to think about all of these pools and reusing. You just drop the task in the thread, yes, make it do, and then throw it away. Let the garbage collector do its job, because once again, this resource is extremely cheap for us as programmers. We don't think how it's underneath, but for us it's very cheap. And this is how it works. So Helidon is fully based on this. That means that we're not supporting some thread pools, virtual thread pools, to offload some of the tasks that no, everything goes this way. Everything goes as virtual threads. And what is the most important part for us as programmers is that the code is much simpler, I would say. So if you take a look at the code of your left, this is a reactive code, which says, okay, send some requests. I'll go there in a second. Send some requests to external services. Then whenever they're done, gather them back and perform some operations to them. So if you're able to read this, it's extremely fast. If you take a look on your right, this is the code that we used to work with. Just create some features. You have 4 cycles here. By the way, let's actually jump in the demo because I've prepared for you. So we have 2 examples, which is blocking and unblocking. Reactive. I hope you can see a license expires. Oh my god, I have to another solution. By the way, I'm really happy that IntelliJ supports Java Champions and gives the subscription for free. So thank you so much. I hope it will be renewed in a few days. Yes. So if we take a code which is, for example, sending some resources in parallel, like here. I'll do it even this way. So you have to create a multi of range of some count workers. Then you have to do a flat map saying that, okay, we have a single of a completable future, which does supply, I think, a call of a client, which is done on this executor. When it's done, we do a flat map of function identity. I have no idea what is this. But then we collect the results back as a list, which is a single, which is, you can call it as a mono, which then map all the stuff in strings, and then if everything is okay, just send it as a response. If something is wrong, we should handle it gracefully in a reactive way. I'll be honest, it took my colleagues at least 40 minutes or half an hour to write this code, just to write this code, not to debug it. So I can't read it, I'll be honest. I'm stupid enough not to read it. But this code is very good in performance. It does really good. But it's undebuggable and understandable. What is good, actually, you see, IntelliJ IDEA tries to help us as much as possible. He said at which moment, what is the return type, so that you can, at least in your hand, understand what is happening there. But I'll be honest, it does work good, but it's not the way it should be. Take a look at the same code in the way that I used to do that in school. So what we do, we send several requests to our clients, and then we gather the result. So how would you do? You have a future, just an array of futures, nothing special. And here, in a for cycle, yes, literally a normal for cycle, we submit all this stuff to send it to other web services as a just a request. I won't go deeper because we don't have much time. Then we have the responses. We have to gather the responses. And here we say, okay, this is the array with responses. And for cycle, what we do, we simply get those responses. And what is important here, get, is a blocking operation, meaning that at this moment, it will block the thread. If it was a usual Java, it will simply block and wait. But here, with the virtual threads, we delegate to the JVM to say, okay, if it's block, give this thread to someone else to do the stuff. So we start thinking blocking, meaning that, okay, put it there and get it back. And as easy as that. So this is the main difference for us. You see, IntelliJ doesn't even write something for us because its code is so easy. And yes, you can take a look at the example. It's in my repo. Once again, because we don't have much time, you can play with it. I can only demonstrate you this small function. By the way, what is good about Helidon itself, I simply run it directly from the IDE and do this operation, curl, curl a lot. And what we have here, I'll give you this function to see. It's a function of a lot, meaning that we just have performed a lot of operations. Where is it, by the way? Yes. What does this function do? No, it's a, wait a minute, it's a continuation. Why am I here? It simply does atomic increment, and every increment is done in a separate virtual thread. That means that with this example, when I clicked it, I created 1 million virtual threads in this machine. It did this this operation, and then we simply stop this thread and throw them away. You see, and my machine did not block, even I'm sorry for the lights. Yes, even though I have even when I have this StreamYard streaming, it takes a lot of the resources. You see, it's not an issue anymore. So, and the other thing is, when I well, let's stop here. And for example, I do debug. Where is it? Yes, main method. Where is the main method? Yes, 1 second. And I just do debug. By the way, I do everything in IDE. Yes, and I, for example, call a parallel method. At some moment, it gives me a normal and very much readable debug information. It's not like all this tons of stuff which comes from the reactive stuff. I can easily debug. I can see what the result is. By the way, you see it's running in a virtual thread, and here is the continuation, which is internal JDK. It means that at this moment, JDK resumed my thread from this continuation, which is happening there. And you see the debugging information is extremely small. You can easily debug. This is what is important for us as programmers when we migrate to virtual threads, and what we do here. So As easy as that. Okay, let's go back. And the other thing is reusing the resources. Everything is done for that. The better you utilize your resources, the less you pay. It means you need less instances for your stuff because blocking is doing nothing. And JVM cares for us that JDK is doing stuff. So what is good about using that stuff in Helidon? As we know, microprofile is blocking by its nature. Most of the stuff is blocking by its nature. So that means if you upgrade to Helidon 4, you don't need to do anything at all. It's still compatible as an implementation. Your application will simply do better because of the virtual threads. That means that if we take a look at the performance, okay, Helidon 4 server in comparison to Netty, there is some change, but if we compare the micro-profile stuff, the typical Helidon micro-profile, which is done with reactive stuff underneath, with blocking and reusing all that stuff, now performs much better with simply upgrading the version of virtual threads. I would say several X's. Yes, they simply have to upgrade, and it is what it is. It is how it happened. Let me show you this small demo. So I have created a, not me actually, this is an example from our architect, Thomas Langer. So we created several servers, which what they do. So there is a blocking request, which I will give it here, for example, to be as easy as possible. There is a quick response, which just say hello. And there is another response, which is slow request, which first sleeps for several seconds and then say hello. While sleeping, it's blocked. That means that it does nothing. And we limited the resource to 10 parallel threads. That means that I can easily show you the result. So that means that we have two clients. The client quick pings the quick endpoint, and the client slow pings the slow endpoint. What should happen? Let me show you in the console. So I have special console group here for the virtual threads. If we start our server, I would say like no loom here. Yes, it starts the server, it's usual Helidon MP server. And now if we start the quick client, I'll actually start with the slow client. JJ targets client slow. Oops. Yes, client slow. Oops. God, I'm very fast. Sorry. Yeah, we'll start pinging our server. It will send 10 requests, and here you see 10 successful results. Now, if I start the slow client, the quick client, sorry, client's quick, you see as the sleeping actually breaks. All the threads are busy with sleeping. The quick client, you see, has a lot of errors. That means all our resources are occupied by just sleeping or doing I/O operation. If we do htop, we will see that our server is underused. It's simply not used with this way. So good. I say not good, but anyway. So the reactive, if we take a look at the reactive, there's a reactive implementation for that, which is, I will do it Java target is target and server reactive. You will see a dramatic change. You see now we perform good with slow requests. We still serve them. And here on the left, you can see that we still serve the quick responses. Let me try to zoom a little bit, if it is possible. Yes. You see, there is a good number of it. So we can see that all this performance, we just simply reuse this time, but just with the reactive stuff, because it's reactive. Now, let me dezoom. And here comes the interesting stuff. So I'll get out of here, put the H top here to monitor. And now, if we do the very same blocking code with Helidon 4th server, which is based on virtual threads, JJ target server 4, I guess. Yes. What would you see? You will see it will now go slow. It will now perform, get warm. That means that now the very same code is much better reused because JVM is taking care of this virtual threads going back and forth. So we have reactive performance, but with blocking code. You see? So with this thing, we're killing two stuff. It's much easier to write, and you have the reactive performance, which is actually, let me try to zoom in a little bit so you can easily see it. You see, the same code, the same blocking code, micro profile code, but performs it this way. So, as easy as that. Let me just wait a second. How do we de-zoom? Hey, it's not working. Yes, it did work. So, as you see, these are real. Now, this is what happens right now, even with the zoom. So, as easy as that. So I will now terminate all processes and get back to the demo. Yep. So what is awesome? Here we're not obstructing the thread. Obstructing means that you long-term utilize the stuff. That means that you're not mining bitcoins or decoding a movie, something. That means that by design, reactive tasks, not reactive, but microservices tasks are cool because you have one small request. We have a lot of them. They're short terms and they're not obstructing the thread. This is why it is a perfect match. So we learned a lot of stuff there, by the way. Interesting thing is that everything that has been done previously, for example, asynchronous sockets, don't work that anymore. That means that you have to use synchronous sockets for better performance, which is impressive. That means that we have to learn doing stuff the old school way, meaning that I have to learn to write again my code the way I did it in 4th grade in school. So we have to really forget how to write asynchronous stuff because blocking stuff was working better with that. We were able to do good HTTP2, good gRPC. You have to still know about some limitations that had happened. First of all, some virtual threads cannot be unmounted. For example, if there's OS level limitation, for example, if you do object wait, it will not unmount the carrier thread. But JVM will compensate this by adding additional temporary number of threads in the thread pool. So be careful with that. Another thing, not as easy as you thought. You have to not do any more synchronized block and not to is not a good word, but be careful with native basis foreign functions. If you want to do it good with virtual threads, you have to use Java util concurrent library and use the reentrant blocked instead of synchronized. This, it will perform correctly. So, lessons learned. We have to unlearn asynchronous programming. Everything is easier to write now. Don't use synchronize, use Java util concurrent. Well, you may think that thread locals, well, it's still available as thread locals, but now as you have a lot of threads, you may have a lot of thread locals. So for example, you have to learn, not learn, but take a look about this JEPs that happens now, about the structure concurrency and scoped values. So, they will help you with moving from scope values to, by the way, I like this picture very much by Mario Fusco. So now, instead of using thread locals, you have to use scope variables, which are coming soon. Yep. Yep. And as an idea, um, take a look at this track. So as a wrap up, because I'm a little bit ahead of, well, I've done a little more time. Instead of high performance, complexity, or simplicity and average performance, now you can have both. Simplicity to write and debug code and still enjoy high performance, which is equals to React. And now, as Java 21 is available, this is not any more an experimental feature. So it's out of the box available to you. And as an idea, what you can do is Helidon 4 and virtual threads. So just give all the complexity of this stuff to JVM and receive a lot of performance and enjoy writing an easy code. And what is good with the official numbers, I really like the official stuff. If we take a look about the Tech Power benchmark, now we see that Helidon is ahead of its competitors in virtual with the usage of virtual threads. So virtual threads are not just something to simplify you, but it actually gives you better performance. And these are the official results. You can see it in benchmarks in Tech and Power. And as far as I see, so whenever you have to play a little bit with Helidon, just here are all the social networks. I'm happy to be part of those social networks. Some of they were created by me, by the way, so I'm happy about that. So just play with it, enjoy it, and actually this is, I would say, the best usage of virtual threads. Just remember one thing, because as far as I see that Mala is about to connect right now, I'll take the advantage to have some time to chat with you more. So if you have thread count which is comparable to your processor, for example, you have 16 or 32 threads in your processor, you don't need to use virtual threads. If you have thousands of threads, as I said previously, with the idea that your tasks are short-term and they are not obstructing the thread, you're not mining bitcoins, you're not decoding movies, you're not doing computations, yes, you don't need virtual thread, because as an overhead, one virtual thread is more than one thread in terms of a usual thread. But if you have thousands of them and you need this resource and you need someone to manage this thing, this is exactly your choice. So that means that JVM will do this for you. And this is already a production feature. So we are really happy that in Helidon we use this feature exactly the way it should be used. So ultimate performance, exactly, by throwing away all these reactive engines. Yes, it was hard and tough decision to remove this reactive stuff. We still keep it for compatibility layers, but underneath is blocking, and it still performs better. And yes, I would like to say thank you for this talk. Yes, and as unfortunately Mala had some connection issues, so I'll be your host for a few more minutes. So whenever you like this talk, whenever you liked the things I said to you, could you please share your feedback with this QR code? Just this survey. I'll be really grateful if you share good thoughts about this, because I sincerely believe this technology is awesome, and this is the best usage of virtual threads so far. I'm quite convinced about this. So please share your feedback. Sergey, he's in chat with me right now. Do we have any questions coming at the end? Yes, this is the best question. The reactive programming make any sense when with the arrival of virtual threads? This is a question from El Mehdi Ben Hadou. I hope I said your name correctly. The answer is simple. No, you don't need reactive anymore. It does not make sense, at least for me. I'm quite convinced that this is the biggest and best change of JVM so far. So you don't need reactive programming anymore for 99% of the cases. Of course, maybe there are scenarios when you need more. I don't know, but even I'm thinking that even the back pressure stuff, all those back pressure mechanisms used there, are actually nicely handled by the JVM itself. So I would say that reactive programming is about to die. This is my personal opinion. I'm sharing a opinion from many JVM guys, and I think that it will come in the future. Like I said, I hope this answered your question. Maybe next question. What is approximate number of virtual threads that a physical core can support from a personal account? Well, I cannot answer this. It really does depend on the hardware, because some of them have hyper-threading. Some of them are good processors with good pipelines. Some of them are tiny ARM cores. So I would say that it really does depend. We're here to the operating system level stuff and hardware support. So I guess I cannot give you exact numbers. Yep. Hope this answers your question. What time does JVM give for virtual thread to be executed? This is a question from Artashonek. I'm not sure if I can answer this question. What time does JVM give for virtual threads to be executed? Well, you see, it depends on the scheduler. If you have more threads, it gives less time. But the internal implementation of the scheduler itself, I must have a look. You may also have a look. Maybe it's a better question to Ron Plessler or Alan Bateman, but it's the implementation of the scheduler. As far as I know, underneath they use fork join algorithm, fork join pool, which means work stealing algorithm. So you just have a look at the fork join pool and have a look at the work stealing algorithm itself, and you will easily calculate it. There is no exact time, I would say. It really does depend on the work. Thank you. I hope this answered your question. Okay, there's a question from Siba already. When virtual thread unlocks, is same carrier thread execute the virtual thread or any other carrier thread? I believe that if the same thread is available, it will execute it because it's easier. But it's not obligatory. It's not. It doesn't have to be the same thread. As I told you from the very beginning, we have M virtual threads running on N threads, and with this continuation, which is a kind of a snapshot of your thread, it's easy to move it across the threads. So it doesn't have to be the same. I hope this answers your question. Okay, have there been done any performance tests comparing widget to Project Reactor, for instance? I guess different program. I guess the only advantage is the different programming style and debugging. This is a question from Ira Gogeta. Nice avatar, by the way. So as far as I see, if you can go back to show my slides. This is the Spring framework underneath, and it performs, I would say, twice as worse for that. Do we have any comparison, especially for Project Reactors? No, we haven't done it this way because we only compare it in terms of framework. Once again, because Project Reactor is a part of Spring, so it still has stuff to handle with the but if you compare, if you look at this numbers, let me just go back here, because here we done some comparison to reactive engine that we have. Maybe it's a good idea to make this comparison. Maybe Daniel Katz, my good colleague, if you are ex-colleague now, if you are watching me, maybe it's a good idea to make this comparison to some virtual thread operations. Although, as you see, flat, it's a little bit different API. But in terms of performance of frameworks, you see that Spring, which uses reactive underneath, does not do it this way. I hope this answered your question. Imaginary number. Ask how extensive does Helidon make use of reflection? Can you compare it to Spring, which uses reflection extensively? Yes, we try not to use reflection as much as we can. I mean, we use pure Java, and if you take a look at the Helidon SE underneath, I'm not sure whether we have reflection at all. I mean, um, uh, no, but we try not to use reflection. If we see reflection in some scenarios, this will be really a rare case which we cannot escape. But we know about this because Helidon does much for compatibility with GraalVM. By the way, I'm quite sure that Helidon is the best implementation, has the best compatibility with GraalVM. And the team cares a lot for not using reflection. So in this case, it's really minimal usage, only where it cannot be used, or maybe some third party which we cannot, like, we should inevitably use reflection. So I hope this answered your question. Giga Chat. Why don't we use virtual thread in Helidon instead of reactive engine? Reactive style is really time-consuming to learn and not an elegant way. Well, this is exactly what we did. So now Helidon SE has fully blocking APIs. That means that there is no reactive style at all. And yes, it happened. Helidon 4. Just use it. Hey, Mala, you're back. Nice to see you back.
Hi, Dmitry. I'm so sorry for
No
a
problem.
lot of things happening. Thank you
No,
so much
but
for
we have
holding the fort.
yeah, we are having a nice conversation with people. So GigaChat, I hope you answered your question. So the idea is now, yes, we use virtual thread. They are blocking. They are fast and easy to learn, easy to debug. In IntelliJ idea, I told you, you saw how easy to do it. So just use it. Yes.
So the next
Okay.
question. Okay. Yes, it's from. No, I think this one is the answer by Simone. Thank you so much. So this is the question. There was one question. I'm not sure whether you answered that already. It was about the scheduling of the virtual threads. It was asked by another person during the beginning of the session. So the question was more about how the virtual threads are scheduled. If you talk about the
Yes, we talked about it. Yes.
okay,
We use it for
thank
join our pool there. Yes, I hope it understood this question.
okay.
Okay, reactive still advantage compared to virtual threads. I mean, if your system is reactive, if your system is in a pipeline, I would say you have reactive from one side and reactive from the other side. It's nice for you to be reactive as well. But in terms of applications, yeah, as I told you, even the back pressure, even the exception handling, you only if your full model is reactive and you think reactively, then it's okay. If you talk in terms of performance, I believe it's very much the same. This is my answer. Maybe I'm wrong, but this is how I know it. So I hope this answers this question.
And I think that's a similar question because it's about comparing both. And so your comments.
Yes, my comment is yes. They are comparing well. They're performing well. They are good. They are yes. You can choose. I would say it a little bit like XXX project manager. If you need to find people on the market who do good reactive programming, it will be extremely expensive. Don't get me wrong. These guys are awesome. There are a few of them, and they are expensive in terms of because they know how to do this stuff. Here, as a manager, I would say that I can hire much. I would say more main. How call it main mainstream people, and they will do the same job much cheaper
Mhm.
with the same performance.
And I think that's a similar statement. And the takeaway which I see is I don't think it will switch to virtual thread soon. So there's a lot of confusion with developers whether to remain with reactive programming and or go full virtual. But you talked about two versions of Helidon that you have.
Mhm.
So I think that pretty much answers.
Well, I would say
Yes.
once again,
Mm-mm,
uh, uh, it really does depend on what you do.
mm-mm,
If you want to create, like, I would believe, well, that's why I say 99, 95, 99% of this stuff can now be done
mm-mm.
without reactive stuff. This is good. This is the basic takeaway.
So this is a question about the link to your repository, the one that you showed, the demo.
Yeah,
So if you have that,
yeah, I
if
will
you have
tweet
that,
it.
okay, perfect.
Yeah,
So
thank you.
please follow Dmitry, and he will have that tweeted on his account.
Tweet and
Again,
Mastodon and LinkedIn.
okay,
Uh,
yes,
is the
all
performance
of this is
similar in both codes?
mm,
Actually, yes, it is quite similar.
okay. So the next one is about the observable pattern.
Well, if you need to use this pattern, then yes. Uh, but if you don't, yes, it's observable pattern done right. Yes, if you use this pattern, like they do a lot of it in Netflix, for example, then yes. But if you are not Netflix, why would you care about it?
So
I hope this answered your question. Yes, it's also there's another question about a guy. It's yes, if your tasks, if you think that way, then yes, it does not stop you from doing this. If it's hard for you to think this way, uh, and you don't have you don't need to choose it between performance, you still have the same performance. This is the main idea.
Right, and I'll take just one or two more questions because we're already over the hour. So this is a question which is specific to Helidon. How does Helidon handle back pressure, and how do you avoid out of memory from too many concurrent requests?
Well, also out of memory. I have to test it more, but back pressure once again. The idea of you get it. I wonder if my question, my answer will be a little bit incorrect. So I would say by this stuff back pressure, um, you can have it like out of the box by the idea that it's been managed. But my solution here, if you really have a lot of many concurrent requests, there are a lot of rate limiters which are available to you. So I'm not sure if Helidon does have its own rate limiter, but there is a very nice rate limiter. Just forgot its name. It's the most convenient. You can rate limit, and that's it. Um, and this will solve everything out of the box for you. I hope this answered your question. Yes, but once again, if you, by the way, if you tweet it somewhere with the at Helidon, I believe the guys from the team will answer you better than I did. Thank you.
That that's a great suggestion. So I'll probably this is the
The
last
last
one.
guy I saw it. Yes,
Okay.
pin
So,
thread. How does Well, actually, it does not. It does not manage. Once again, threads are how it does things. So for each port, when you open, there is a thread, and for each request, it opens a virtual thread. So for other stuff, there are just threads that are used to have. For HTTP2, we have two threads for virtual threads. For HTTP1, we have one virtual thread, as far as I know. Once again, the virtual threads are for requests. Other threads are managed a little bit differently. Whenever we see there is a way we can use virtual threads there, there are certain situations where virtual threads can be used. Then yes, otherwise you just use normal threads. Yes, for requests, the virtual threads are the most important. So each request is a virtual thread.
And
Yeah.
Vladimir also pointed out that since virtual threads are in production feature in 21, so
Yeah.
if folks are on the previous version of Java, they'll probably have to stay with reactive paradigm, which
Yes.
is
Yes.
sad, but yeah,
This is
yeah.
this is this is yes. This is most important. If you want to use them, you have to switch to virtual to a Java 21. Um, oh, yes.
So
By the
that's
way, hello
yes.
Vladimir. Nice to see you. Has written most of that on reactive as reactive programmatic for GraphQL. By the way, we solved this internally very good with virtual threads for Helidon. So yes, you have to move to Java. By the way, it's always a good idea to move to Java 21. I don't know why people don't
Yeah.
do this.
If things
Yes.
work, let them be in that state.
Yes,
If
I
the,
know. I know.
I
Enterprise
know.
is bloody
Yeah.
enterprise, and yes. But
Mhm.
I suggest you to talk to your managers to move to Java
Mhm.
21. This is my suggestion.
Mhm.
Thank you so much.
Because and we know that with every new release of Java there are a lot of tons of additional performance benefits
And
that people
security
get.
benefits.
Yes, security benefits, yes, so that's really important. So I'm not sure, Sergey, if you've already showed the QR code for the feedback.
Yes, we
uh,
did.
oh, I'm so sorry for repeating a lot of things that we already do. Thank you, Dmitry. It was such a pleasure to be learning from you. I learned tons of things. And everyone who's watching, thank you so much for watching, for your questions, for your participation, for answering. And I really hope you learned a lot from Dmitry's session. Here are the social links. If you want to ask any other question, as Dmitry said, you can ping him and probably he'll be able to answer depending on how the time works, because he's a busy person. We know that. So
Oh, I'm now enjoying sabbatical, so
ah,
I'll do my
okay.
best to answer them, or maybe direct it to the right person who is responsible for that. Thank you so
That's
much.
Thank you so much. And everyone who's watching, stay tuned. Okay. And yes, don't forget to subscribe to our channels and do not miss the next live stream that we will host on 29th of February by Anton Arhipov, in which we'll talk about improving the code quality with Kodana and IntelliJ IDEA. And we have some thank you messages coming in. And people are saying thank you. And Philip, and here's David. So thank you so much,
Great
Dimitri.
pleasure. I hope it was
Okay.
useful. Thank you so much. Goodbye.
Absolutely. Bye bye.